Right now, somewhere in a drawer next to you, there is probably ibuprofen. Antibiotics are a prescription away. If something goes seriously wrong, a broken bone, an infected cut, a fever that climbs past 104, a hospital will be open tonight, staffed, lit, and waiting. Take all of that away. Take away the drawer. Take away the hospital. Take away every molecule of manufactured medicine that has ever existed. Now put yourself in a body 50,000 years ago, in the forests of what will eventually become southwestern France, with a gash across your forearm that is already starting to smell wrong. Most people assume ancient humans just died, constantly, from everything. So how did they actually survive? In 2017, a team of researchers at the University of Liverpool published findings on a Neanderthal skeleton recovered from Shanidar cave in northern Iraq, a site that had been excavated since the 1950s. The individual, known as Shanidar 1, had survived to an estimated age of 35 to 45, which, for a Neanderthal, represents old age. That alone is not the surprising part. What the skeleton showed was that this individual had a withered right arm, likely amputated or severed above the elbow, along with a healed, crushing injury to the left side of the skull that had left him partially blind and probably deaf in one ear. His legs showed signs of repeated trauma. He could not have hunted. He could not have foraged effectively. He survived anyway, for years. That means someone fed him. Someone kept him warm. Someone cleaned his wounds. The real medicine 50,000 years ago was not a substance. It was a social contract. But here's where it gets strange. Ancient humans were not simply enduring illness through community alone. They appear to have had a working pharmacopoeia, a collection of plants, resins, and compounds used as deliberate treatments, long before anyone wrote any of it down. In 2019, researchers from the University of York analyzed dental calculus, the hardened plaque scraped from Neanderthal teeth at El Sidrón cave in Spain, and found chemical residues of yarrow, groundsel, and poplar bark. Poplar bark contains salicin, the natural precursor to aspirin. The individuals showed evidence of severe intestinal parasites, and the plants with no caloric value were consumed anyway, suggesting deliberate self-medication rather than accidental ingestion. The research was published in the journal Nature and represented the oldest direct chemical evidence of plant-based medicine, dated to approximately 50,000 years ago. 50,000 years. The aspirin in the drawer is not as modern an idea as the packaging suggests. So what else was in the toolkit? Everyone assumes wound care is a modern problem, that infection was simply a death sentence before antibiotics. The truth is that Homo sapiens groups across sub-Saharan Africa, Australia, and the Amazon independently developed wound treatments involving antimicrobial plant compounds, and the evidence suggests these treatments worked at measurable rates. Anthropologist Daniel Moorman spent decades compiling a database of more than 44,000 medicinal plant uses across 305 indigenous North American cultures, published in 2009 through Cambridge University Press. The recurring pattern he found was not coincidence. The same plants, or plants from the same botanical families with the same active compounds, appeared across cultures with no contact history. Honey, used as a wound covering for at least 8,000 years based on Egyptian records and archaeological traces, inhibits bacterial growth through its hydrogen peroxide content and low water activity. When researchers at Cardiff University applied Manuka honey to antibiotic-resistant Staphylococcus aureus cultures in controlled laboratory settings in 2011, it eliminated the bacteria in 98% of cases. Ancient wound care was not wishful thinking. It was applied chemistry, worked out empirically over generations by people who had no margin for error. Here's where the picture gets more complicated. The skeleton record does not only show survivors, it shows people who should not have survived. In 2018, paleopathologist Jane Buikstra at Arizona State University published a review of healed bone fractures from pre-contact archaeological sites across North America. Fractures that today require surgical pins, immobilization, and months of physical therapy were healing, imperfectly, often with visible misalignment, but healing, in populations with no metal tools and no knowledge of germ theory. The human body, in the absence of any intervention, heals a broken femur in roughly 3 to 6 months on its own. A broken rib reconnects in 6 weeks. The biology predates the medicine by millions of years. What the pre-modern world supplied was not primarily drugs. It was time, rest, food, warmth, someone to sit with the injured person through the night. And, critically, the knowledge of what not to do. Anthropologists studying traditional healing practices across cultures have consistently found that the most sophisticated element is often harm reduction, knowing which treatments make wounds worse, which fevers should not be suppressed, which plants cause miscarriage, which interventions accelerate bleeding. The medicine was often the restraint. But there is one more layer, one that modern medicine has only recently begun to take seriously. Everyone assumes the immune system of ancient humans was basically the same as ours, just facing more threats. The evidence suggests something more unsettling. It was significantly stronger. In 2016, a team led by immunologist Jean-Laurent Casanova at Rockefeller University in New York reviewed data comparing immune response profiles in isolated contemporary populations, groups with limited contact with industrial society, against populations in Western urban environments. The findings, published in the Journal of Experimental Medicine, pointed to measurably lower rates of autoimmune conditions in traditional populations, alongside higher baseline tolerance for common bacterial exposure. Separately, research from the University of Nottingham, published in PNAS in 2015, examined ancient DNA from European skeletal remains dated between 3,000 and 8,500 years ago. The genetic data showed that key immune gene variants associated with inflammatory disease became more common only after the widespread adoption of agriculture and sedentary life, suggesting that the hunter-gatherer immune system was calibrated for a world of constant microbial exposure, and the modern immune system is, in a measurable sense, poorly adapted to the world it now lives in. Ancient humans did not just survive disease with fewer tools. They walked into a world of pathogens with a body better equipped to handle them than ours. So pull the frame back. There is a person in a cave in southwestern France 50,000 years ago. The gash across that forearm is being cleaned with yarrow, packed with honey, and wrapped in bark. A fire is burning. Someone is sitting close. The body is already beginning to knit the wound from the inside, because that is what bodies are designed to do when they have time, warmth, and social support rather than isolation and cortisol. They did not survive despite the absence of medicine. They survived because they understood, without ever writing it down, that medicine was never primarily a substance. It was always the act of one person staying with another until the worst was over. The pharmaceutical industry invented pills. Ancient humans invented the harder thing, the willingness to keep someone alive just because they were there.